3 million earthquakes, mostly undetectable, happen every year around the world, out of which India accounts for 20,000 of them. India also accounts for one of the deadliest floods on the planet, including the Kedarnath landslide and flooding that killed 807 people that year. In addition to these, many cyclones injure and affect at least 10 lakh people every year. 42% of land in India suffer from drought, affecting the farmers adversely. Aside from these stats, millions of Indians are being affected by natural disasters every year. To tackle this problem, we have designed a model and we are calling this terrain. So let's explore the model.
Hello everyone, I'm Ramahani Shagunda and my contribution to this project Terrain is to do the background study and also to make an activity diagram. Thank you.
Hello everyone, my name is Aditya and I am a team member of the project Terrain. My task is to create a mobile application using Java and Kotlin for the Android framework using various APIs ranging from weather to geospatial data to atmospheric conditions to soil compositions. Thank you.
Hello, my name is Priyanshi Kedia and my contribution towards the report has been the project planning and making the use case and the class type.
Hello, my name is Orange Banerjee and my contribution to this project Terrain was to make the sequence diagram and come up with user stories and sprints.
Since the beginning of recorded history, you see, surveying has been a very important part of the evolution of the human environment. It is a valuable research tool in many other scientific disciplines. Understanding topography is important because you see, ground data can be used to save lives and property on a large scale. Not all available seismically stable regions are suitable for large-scale construction. Similarly, not all soil compositions lend themselves to all types of farming and agriculture. Much of the fertile land has been depleted all around the world, which results in the lowest crop yields. Most farmers in India still use an old-fashioned method of soil cultivation, which is both outdated and inefficient. This is a serious problem for a country like ours that is estimated to be the world's populous country. So what do we do? So what exactly are we implying to? Moving on to the problem statement, we would like to address you exactly what is the problem that we are facing or addressing in our project Terrain.
During 2020, India's ground trembled more than 400 times with a Richter reading of 4 or above, with 100 more sub-4 readings. For a country like India, which aims to join the $5 trillion economic club in the recent future, these tremors proved to be a great threat for the rapidly developing infrastructure of the country. Huge capital has been invested in building megastructures like LIGO, modern power plants, wind farms, financial centers, smart cities, and many others. This is a serious issue for a country that is estimated to be the most populous country in the entire world.
The proposed solution is an application that displays detailed topographic information based on geospatial location. With the aid of satellite information, the application also shows data concerning seismic activity, soil structure, and atmospheric conditions.
The resources that we are using in this project are Java. Java is developed by Oracle and it is a class-based object-oriented programming language that is designed to have as few implementation dependencies as possible. Then we have the cloud storage. Now what is cloud? Cloud is basically a data storage in which digital data is stored in logical pools. These logical pools are known as cloud. We would be using the cloud storage to store information about the users, the farmers, the meteorologists, API information, all the data. Then the next we are going to use is Kotlin. Kotlin is a cross-platform, statistically typed general-purpose programming language with type inference. Kotlin is designed to fully interpretate with Java, and JVM version of Kotlin's standard library depends on the Java class library. Kotlin is designed by JetBrains. Then we have Python. Python is designed by Guido van Rossum. It is an interpreted high-level general-purpose programming language. Python's design philosophy emphasizes code readability with its notable use of significant indentation. It is a much easier language. Then we have SQLite, that is going to be a database management system. It is contained in a C library. It is contrast to many database management systems. SQLite is not a client-server based data engine. Rather, it is embedded into the end program. It is developed by Richard Hipp. What exactly are use case diagram? Use case diagram is used to model the system or a subsystem of an application. They generally consist of the actors, use cases, and their relationships. Why do we need them? They are used to gather the requirements of a system. They are used to get an outside view of a system. They are used to identify the external and internal factors influencing the system, and they are used to show the interaction among the requirements or actors. The use case that you can see on the screen, we have only one actor, that is the user, that has relationships with different use cases that are denoted in a purple block and a blue block. The relationships amongst each use case is either included or extended, as we can see.
Before explaining the activity diagram of our model, let's know what an activity diagram is. It is a diagram that shows activities and actions to describe workflows. In UML, an activity diagram represents the business and operational step-by-step workflows of components in a system. An activity diagram shows the overall flow of control. Now let's discuss about the activity diagram of our model. This black node indicates the start of the activity diagram, and this black node with a border indicates the end of the diagram. These diamonds are the decision nodes, which gives us options to decide whether we want to do this or this. And then this is the fork node, and this is the join node, which joins all the decisions and gives the same output. These rounded rectangles are the actions or the activities that can be performed. So let's start. After we start this, we get a decision node to decide whether we want to log in or we want to sign in. If we didn't sign in earlier, we'll go with the sign in option. If we have already registered or signed in, we go for the login option. Let's see both of them. First, let us sign in. After going into the sign in, we need to register ourselves with our details, which will be asked by the application. After that, we will log in. After logging in, it will check whether our username and the passwords are correct. If it is correct, it will go to this node. If it is not correct, it will go to this node. As it is written unsuccessful, this will again go to the login page. We need to check our details again, and then again this process continues. After logging in successfully, we get again a decision node where we get three options: whether we want to check the weather data, topology, or the geospatial information. After selecting any of these, we will get the current update of the weather or topology or geospatial information. What this process does is, after we come here, it will go to the database, it will search for the update, in that particular location we are searching for, and then it will view the update. After viewing the update, we get the final result. It will give an option whether we want to see more, like we want to check weather of any other state or any other place, or you want to check a topology now of the same place, something like that. If you want to view more, then we will go to the S option and it will take you to the same place where you have three options. You can go further. If you don't want to view more, you can end the process. So this is the activity diagram of our model.
Coming on to the sequence diagram, as we can see that there is this one user, which is the actor, Then we have objects having different timelines which are placed parallelly. Well, the weather section, the soil section, and the earthquake section are three objects that have reflexive messages, namely update weather, update info in the location, and update info in the earthquake section. We have repetitive messages such as checking of the earthquake prone areas. Then we have view details in case of the weather section, and specific farming conditions in case of the soil section. Logging to the app gives us a logging success as a message. It's a synchronous message, as you can see. There is a return message from the user to the weather section where they request weather info and the weather section acknowledges and provides them that. After login success, we can reach to the repetitive messages only, or else the repetitive messages would not work. There is another returning message, from the user to the earthquake section requesting info again. There is a synchronous message from the API to the data which gets the summary of the entire data. And there is an entire loop with no specific guard condition as such running, with few return messages requesting reports from the API itself. And the data itself, or the data lifeline itself, provides us a summarize function, or you can say it's a reflexive message in itself. So that explains the sequence diagram for our project Terrain.
Class diagrams. What exactly are class diagrams? They describe the attributes and operation of a class and also the constraints imposed on the system. They generally consist of classes, interfaces, associations, collaborations, and constraints. Class diagrams are the only UML diagrams which can be mapped directly with object-oriented languages. Now the question comes, why do we need a class diagram? So the class diagram is the analysis and design of the static view of an application. It is used to describe responsibilities of a system, and it is the base for component and deployment diagrams. The class diagram that you can see on the screen has 6 classes. Each class has their own attributes and functions that is differentiated by a line. The starting of every attribute and function, there's a plus minus sign which indicates if that particular attribute or function is included in the other class or not. Now you see the user class is a part of farmers and meteorologists, as their attributes in the user class is both required by farmers and meteorologists. Then we have the soil, weather, and earthquake. The soil class has its own attributes and it's been used by only the farmers to detect which soil, if it's good for farming or not. And the weather class will have its own weather API, its own attributes, and it's used by both meteorologists and farmers. For meteorologists to help in detection of earthquake, weather conditions, and for farmers for soil and which kind of crop they can grow. Similarly, earthquake is only needed by meteorologists that contains several other APIs and also attributes for meteorologists to detect earthquakes.
Data architecture describes the structure of an organization's logical and physical assets and data management resources. The goal of data architecture is to translate business needs into data and system requirements and to manage data and its flow through the enterprise. It is the blueprint for managing data assets by aligning with organizational strategy to establish strategic data requirements and designs to meet those requirements. In Terrain, we get our data and move it through different points during which it goes through several processing and filtration techniques before it gets handed over to the user for analysis, more of which can be seen from the screen.
To summarize, we have seen the objective of our project along with the problem statement and solution we are working on, the resources which will be used in the project, and lastly, we explain the use case, activity, sequence, and class diagrams along with data architecture diagram. Thank you. Have a great day.